What is up, athletes? So happy Sunday for those of you listening on a Sunday. I'm going to jump into 8.2, quick little video here um, to help you out with T intervals, confidence intervals, distinguishing when do I use T interval versus Z interval, right? Looking at all those important ideas. All right. So in this case, they want us to find the critical value of this T value here, right? So what is this going to be needed? So what is this needed to construct a confidence interval of a given level with a given sample size? So what they're going to give us is they're going to give us a confidence level, right? And they're going to give us a sample size. The sample size is going to influence something called our degrees of freedom. Your calculator is going to call that DF. So basically what you do is you take your sample size and you just subtract 1. All right, so let me show you what this looks like. So remember that 95% and sample size of 19. So if I go into my calculator here, we're going to go to stat test, and we are going to go down to we have Z interval and T interval. So these are the programs that are going to give us intervals, all right, the confidence intervals. But right now we're not there yet. And that's a mistake I see people making, is they're trying to use this for this question. All right. So whenever we just want the Z value or the T value, we're actually going to use second vars. So that's second distribution, because that gives us these two programs. So inverse norm gives us our Z value, our Z score, and this gives us our T value. So they want a T, so we pick number 4. We want the area. So when we pick our area, this program wants the area to the left. All right. So essentially what you're doing, just so you understand how this looks, is if I have my normal distribution, that middle 95, that middle area is 95%, right? So that means the total of these tails is the remaining 5%, because remember, everything adds up to 1. All right, so the remaining is 0.05. Well, how many tails do I got? I have 2. So each one of these tails, right, this tail and this tail, is going to be 0.05 divided by 2. So 0.025. All right. So that's how you figure out what that left tail is. So again, all we did is we first found this middle area that was given, 0.95, and we do 1 minus that, which gives us this, right? So this is 1 minus 0.95. So that's the area of these 2 tails. And because I have 2 tails, that's why I divided that 0.05 by 2. And so this area right here is 0.025. So that's what's going to go into my calculator. All right. So we put in 0.025. And then the next thing it wants is DF, the degrees of freedom. So in our question, it said our N, the sample size was 19. So this is going to be 18. It's always 1 less. So write that down. All right. And then let's see, let's make sure. I forgot the decimal here. Let's do that one more time for the East Coast. Clear. Second R's, inverse T, 0.025. And then we said it was 19, so 1 less than 19 is 18. And there's your Z score, or your T score, excuse me, that T value. So let's go back to the question. And when you hit this button right here, it says explanation. It's going to walk you through exactly what I did there. All right. And you might be wondering, this is why I do it different. Because notice what they do is they take that 1 minus the 0.025. And so if I'm drawing this, right, let me show you what your program is doing, which in my opinion is much more difficult than what we just did. So they got the 0.95, and then they saw that this was 0.025. So they did one minus this, and that gave them 0.975. All right. So their calculator gives you this, which is the same answer that we got when we used, oops, let me go back. When we used ours, the only difference was in ours was negative, right? Why is that? Well, when you're looking at these t-scores, you're gonna have this answer, and actually, no, you're right. So this t-score, we found it to be 2.101, and our answer was negative 2.101. And all that means is we found the left value. But again, these values are always going to be the same. All right. So all you have to do is make it positive. So then you could kind of skip all this stuff. So I would ignore their explanation, even though it does make sense. In my opinion, it's just harder and longer than what I did. All right. So, because again, I noticed on the homework, people are struggling with that. All right, let's look at another question here. Question 2. All right, question 2. Now let's get one that has, well, let's read it. So you got these two people, they're going to construct confidence intervals for the same simple random sample. Joe's confidence interval will have a 90% confidence, all right? And she will have a 95% confidence. So which will have a larger margin of error? All right. So whose confidence level will have a larger margin of error? There's two ways we could think about this. All right. And so the first way of thinking about it, they might give you, let's see. Let me just see. They don't give you, wow, they don't give you the formula. So what I would do, let's read what they did, but I'm going to take a different approach. So notice her confidence level is higher than his. So it says, other things being equal, it is better to have more confidence than less. We would rather have a smaller margin of error than a larger one. However, when it comes to confidence, there's a trade-off. If we increase the level of confidence, we must increase the critical value, which in turn increases the margin of error. So what I want you to do, because that might make sense to some of you, but what I encourage you to do is always look at our formula. So if we look at our formula, let me write it down for you, just so you can kind of connect the dots. We have x bar plus or minus t times s over the square root of n. So remember this part that I put in parentheses, this is called our standard error. And this that I'm going to box is called our margin of error. So when you increase the confidence level, what happens is if the confidence level, I'm going to put if CL, the confidence level increases, what that means is this t value gets bigger. T gets larger. T gets bigger, right? So if this is bigger, if this t value is bigger, that means this whole thing is going to get bigger. And this whole thing that I boxed is called your margin of error. Margin of error. You have more wriggle room. You're more confident, right? Your basket, your hoop got bigger that you're going to shoot the basket into. All right, so there's more room to make a mistake. So if your confidence level, the more confident you are, the spread is going to be wider, right? The narrower that spread is, the less confident you are. There's less room to make a mistake. All right, so in your notes, put if your confidence level increases, your margin of error increases. All right, so, but you can now see that because of the formula, because that confidence level directly impacts your t-score in this case. And so when that t gets larger, this entire thing gets larger. This margin of error gets larger. All right. And part B, which confidence interval is more likely to cover the population mean? All right. So again, we just stay consistent with that formula. And it says, since this confidence level 95% is higher than 90%, her confidence will be more likely to cover the mean. So basically, the numbers that are going to come out of this, because this is bigger now, there's more likelihood that this is going to cover the true population. If we're thinking about this using numbers, let's think of a number line. All right. Let's say you're trying to guess my age. Let's just make sense of this. So let's say, you're looking at my video right now, and let's say two people guess they give me a range. So one person, what they're going to do is they're going to say, you know what, Dr. Math here is between 29 and 35. All right. And this other person is going to look at me and they're going to be more confident. And when they say more confident, that means is they're going to take a guess and they're like, you know what, Dr. Math is actually between 25 and 40. All right. So my true age is more likely to be in which interval, this purple interval or this red interval? Well, we could clearly see this red interval because this red interval has a larger confidence level because it's wider. So this has a larger confidence level, right? Because that means it has a bigger margin of error. There's more room to make a mistake. All right. So I hope that helps out with that idea. All right. So let's continue the march here. Number 3. Same idea for that question. All right. So in this case, they want us to construct a 95% confidence interval, and then they give us this information. All right. So now when I go to my programs, which program I'm going to use? So this is the big hitter. You have to identify what standard deviation do they give you? Do they give you a population standard deviation, or do they give you a population standard deviation? So when they give you S, right here, when they give you S, that's going to tell you you're going to use tInterval. All right, you're going to use that program tInterval. I should have just wrote it by not using the mouse. tInterval. All right, so that's the big thing, really. That's like our cheat code, right? Because I know a lot of people just want to know what program am I using. So when I jump to question, and we'll do one right now. When I jump to question 7, as you're reading this, look at the standard deviation. You always want to read the problem and understand where is the standard deviation coming from. So it says phonics is an instructional method in which children are taught to connect sounds with letters or groups of letters. So a sample of 136 first graders who are learning English were asked to identify as many letter sounds as possible in a period of 1 minute. The average number of letter sounds identified was 34 with a standard deviation of 23.32. So the big question you're asking yourself is, where is this standard deviation coming? And this standard deviation is coming from this sample. So if I were to, first thing I do is I write down everything they give me. They gave me N is 136. They give me X bar is 34.1. And then they give me S is 23.32. And because my sample size is large enough, what I could do now is because of this S is given, I'm going to go and look for this program, tInterval. All right, so I know I'm going to construct a confidence interval, but which one am I going to construct, a Z interval or tInterval? So let me take a picture of these numbers because we're about to enter these numbers into our calculator. I don't want to forget them. All right, so now let's go to our calculator so I could show you the program. So let's go to here. Oops. Let's go here to our calculator, and we're going to go to stat, test, and go down to tInterval. Yours is going to look nicer than mine. And make sure stats is highlighted because they give us the actual statistics. I'm using this free version on my computer, but your calculator is going to probably look nicer than mine. S, my standard deviation of the sample, 23.32. And then my sample size for this one was 136. My confidence level Oh, darn it. What was the confidence level? 99.8%. So 0.998. And then hit calculate. Enter. And there is our lower and upper right there. All right. So it's that easy. But again, it all starts with which standard deviation is given to us. So again, let's just take a peek here. And notice when you're using this program, they're not going to give you all of those tips, right? It's a good program, but it doesn't give you all those tips. So they get the same answer we do. And so our confidence interval is 27.8 to 40.4. All right. Part B says if 98% confidence were constructed with this data, would it be wider or narrow? So I don't even have to, run the numbers again. I just know that if our confidence level goes down, because remember, I was doing 99.8% for that last problem. What's going to happen is when your confidence level goes down, when that percentage goes down, your margin of error becomes smaller. So that means your confidence interval is more narrow. Those numbers are closer together. If you want a wider confidence interval, then you got to increase your confidence level. All right. So again, just make sure you're making those notes down. So bigger confidence level, the wider your confidence interval. All right. And let's just take a look at one more. And so notice in this one, you're going to do the same exact thing, but you want to make sure you enter all these into one of your lists. So make sure you go to maybe list 1 in your calculator, and then you're going to enter in all those data points, just like we did here. But this time when you use tInterval, and notice, why are we using tInterval? Because nowhere here do they provide you with a population standard deviation. It's not given. All right. So you have to use the sample standard deviation, which is going to come from here. All right. So you're going to go ahead. You're going to enter all your numbers in. Press stat. And then you're going to go to test, tInterval, just like we just did. And make sure that you provide them with the confidence level, in this case, being 90%. All right. So when we interpret the data, we say we are 90% confident that the mean rate is between this number and this number. So what that means is if we did this test 100 times, right? 90 of those times, the true population rate, the true mean rate, population rate would be somewhere in between these numbers, right? 90 out of 100 times, because that's our confidence level. All right. Let's see. It says 1 week earlier, the mean rate was this right here, 4.1216. The broker claims that the mean rate is now higher. So based on our interval that we just got, is it true? Is it reasonable? Well, notice both of these numbers are higher than this mean rate, right? So because both of these numbers are now higher, that means the true population mean is somewhere in between here. Regardless of where it falls in here, any number that you give me is going to be higher than this mean rate. So we say, yes, it is reasonable to believe that the mean rate is now higher. All right, folks, I hope this helps you. I hope you're having a great Sunday. If you're listening on Sunday, have yourself a wonderful day, and I'll talk to you guys later. Peace.